Okay, sorry. Now here we are. I started to record the meeting. Good morning, everyone. I think we can start, even though participants are still joining. There is someone with the microphone open. Okay, now it's better. Good morning, everyone. Thank you for joining us to this event for World Soil Day. I'm Riccardo Gambini. I'm Policy Officer of ECN, the co-organizer with Flaco of this webinar. This year, the theme is Soil Where Food Begins. Just before giving the floor to Crystal, I would like to just tell you some housekeeping rules. So the questions for the speaker will be written in the chat, and I will, I will tell them to the speakers after their presentation. And also we have prepared some interactive questions to keep you involved. So we will have the questions launched directly here on WebEx. That's please mute yourself if you're not the speakers, so there's no interference with the with the correct plan of the webinar. And thank you for joining us. And I will give you the floor to Crystal, General Coordinator of Flaco and the President of ECN. So Crystal, the floor is yours.
Thank you very much, Riccardo. And good morning, everybody. And also thank you, everybody, for joining us today on World Soil Day. This year, as Riccardo also has already mentioned, the theme chosen for the World Soil Day is Soil Where Food Begins. And just by listening to these words, it's clear that soil is a natural resource that delivers functions which are fundamental to sustain life. Nonetheless, we are well aware that many European soils are dealing with a lot of pressure caused by unsustainable management, by pollution, climate change, other drivers, often leaving them in very bad ecological conditions. So this means that these soils cannot provide the services they are supposed to. And one of the most important is, of course, to grow food for people and other living beings. And this is why we are here to celebrate this important Awareness Day, but also to discuss possible solutions to safeguard and remediate our lands. In this regard, fertilizers and soil improvers produced out of biowaste, they can play an important and significant role in re-establishing healthy soils, and we will hear more about this today from our speakers. They will explain what is the potential of compost and digestate and how they can contribute to many of the objectives of the EU Green Deal. We need, of course, high-quality compost and digestates, and therefore certification schemes play an important role to assess the properties of these products in order to be safe for use in our soils. So let's go to the first speaker, Alberto Alberto, I always find your surname very difficult. So Alberto, I know you very well.
Let me help you. Confalonieri.
Yeah, okay, thank you very much. So Alberto has been working in the waste management sector already for more than 20 years and mostly dedicated to bio-waste recycling. And he has worked for bio-waste recycling technology suppliers, and then as a researcher in a non-for-profit Italian company. And since 2018, as a senior member in the technical staff of CIC, where he also chairs the technical committee. He also has been involved and done a lot of work in several ECN working groups. And since 2020, he is the chair also of the task group on soil and organic matter. So Alberto, I give you the floor.
Thank you very much, Chris. Good morning, ladies and gentlemen. Thank you, Riccardo, for introducing the meeting. I'm sharing my screen because I have a presentation to share with you. Just tell me if you can see the presentation, please, in full screen mode.
Yes, we can see it.
Okay, let's start. Good morning again, everybody. It's a pleasure for me to celebrate with you the World Soil Day. That means to me celebrating both the importance of soil as a poorly known ecosystem of soil fertility, but also, in my respect, the closure of the loop of organic matter that flows through our lives as food, as grass and branches of trees of our gardens, part of which become waste and must return to soil after being transformed in organic fertilizer. And that's why I would like to start my presentation by showing you a few data that highlight that the bio-waste recycling into new products is at the same time a consolidated reality in Europe, but also a huge opportunity for improving the European circular economy system. In fact, according to the most recent data collected by ECN through its last data report, in the EU 27, the EU 27 collects and recycles around 38 million tons per year of bio-waste, mostly generated by citizens through separate collection of their food and garden rejects. And this allows to state that bio-waste recycling industry has developed along the decades and counts on a robust and reliable background. On the other hand, or at the same time,
Goeiedag Albert.
Sorry, I hear somebody speaking. Why gone? I was saying that the other side of the story is that in order to meet the municipal recycling targets that the US introduced through the circular economy package in 2018, we estimate that this amount should at least be doubled until 2035. And we must create all the conditions, all the policy conditions to make it possible. In this respect, several countries have already put in place bio-waste recycling chains, and bio-waste recycling chains start with the implementation of separate collection schemes. As we can see in this map that shows the per capita bio-waste capture rate throughout Europe, in some countries, separate collection needs to be still finely tuned in order to increase collection rates and captures, while in many others, above all the eastern countries and Greece, for example, are still lagging behind, and most of bio-waste is not separate collected so far, and but unfortunately sent in landfills, sent in incinerators, losing resources and producing greenhouse gases. In any case, one shall always remember that a successful waste recycling chain is made of different steps: collection, treatment, and product utilization, each properly functioning to allow the whole system to work. Each step must be supported by research, technology, and above all, favorable policies. I think that my presentation is not being shared anymore. I hope that I've solved this. Okay, and I was saying that with respect to all these steps, in the World Soil Day, we concentrate on the last step, namely the qualification of the soil improvers that are the main products of organic waste recycling. Many countries are provided with guidelines on bio-waste recycling and national standards for compost and digestate. The EU itself has provided standards for waste-derived soil improvers, first in the Eco-Label regulation and most recently in the regulation on fertilizing products. Quality assurance is a precondition for placing compost or digestate-based fertilizing products on the EU market. Several countries have developed their own quality assurance schemes, and ECN has implemented a harmonized European QIS for compost and digestate since early 2000 and periodically upgraded. And currently 5 countries have been awarded with the ECN QIS, covering around 25% of the overall compost and digestate produced in Europe. Besides compost and digestate quality aspects, it is crucial that organic waste soil improvers are recognized and supported as useful instruments to preserve soil fertility and support unhealthy soil restoration. And to this purpose, ECN several years ago has established among its working groups a specific task group on soil and organic matter that I'm pleased and honored to chair since 2020. This group counts almost 30 participants among ECN members, ranging from representatives of national associations, private companies, university, consultants, and I take the occasion for thanking them all. The purposes of this task group are those you can see in this slide. So raise awareness on the importance of soil organic matter, strengthening the organic cycle, and showing the benefits of soil organic matter. As you can imagine, in this particular historical period, the upcoming regulation on soil is a crucial passage for consolidating the role of organic waste soil improvers, matching waste management with soil protection. So the activity of the group has been very intense and productive, and meant to collect and summarize it in a few papers benefits and opportunities related to compost and solid digestate production and application. Just to mention the last documents produced by the group between 2021 and 2022, these are the headings of the papers: a position paper on the possible guidelines for incentivizing organic waste soil improvers, followed by an info paper on examples of national or local plans allocating resources for soil management practices, that include the utilization of compost, and finally a position paper on the role of organic waste soil improvers within the carbon farming initiative. And now the board of ECN has just approved the outcome of the last efforts of the task group. That is a position paper on the importance of recycled organic waste soil improvers in the frame of the upcoming soil health law, whose contents I'm about to show you. Through these documents, alongside with highlighting the features of the organic waste soil improvers that allow them to bring benefits to soils since sources of stable organic matter and nutrients, we have collected and evaluated the results of several long-time field trials of compost application, showing in the paper the main outcomes. And in order to do this, we have gathered 11 studies, selected among those provided by the task group members. Four of them were coming from scientific literature, and while 7 were of different origins, reports of trials founded by National Composting Association, environmental ministries, research programs, etc. And the main filters that we applied to select the trials, among which we used, were, first of all, that all the studies were coming from several countries: Italy, Germany, Austria, UK, Belgium, Sweden, were run on full-scale open field trials. All the trials were at least 2 years long, but many more were lasted more than 5 years. All the organic fertilizer applied were compliant to a QIS, or at least to a national legislation. I have a message, sorry. Okay. But how did we? Oh, sorry, I can't go on with my presentation because I have accepted something that I shouldn't have. I'm sorry. Okay, sorry for the delay. So going on, how did we evaluate the results of the trials? In light of the upcoming soil health law, we have chosen to use the applicable soil health indicators provided by the European Environment Agency in a draft report called Soil Monitoring in Europe, Indicators and Thresholds for Soil Quality Assessment. And these indicators were soil organic carbon, nutrients, acidification, heavy metal contamination, biodiversity, erosion, compaction. All indicators but erosion, all indicators but soil erosion were evaluated by at least one study, but many of them were evaluated in several or most of the studies. And as an additional parameter, since it can indirectly attest soil fertility associated to virtuous soil management practices, we have considered even crop yield. And let's go to the results, starting from the main parameter, which is, of course, soil organic matter. This parameter has been evaluated by nearly all studies, all reporting positive effects compared to untreated or chemical fertilization. We know that the application of organic fertilizer should not be a one-off event, but an activity to carry on every year or every second year or third year, depending on the specific situation. But it is interesting to see that in some cases, the stockings of soil organic carbon lasted for 3 years after the last compost application. And then after the soil organic carbon nutrients were also widely investigated by the studies. In this case, not only the studies show an increase in nutrients in soil supplied with compost, but their availability, the improvement in their availability for crops. And considering that nitrogen is mostly incorporated in organic matter and mineralized by soil microbiota, often availability is maximized in the most demanding period for crops. Soil compaction, again, is very important. It was investigated by 7 studies, so most of the studies, showing benefits in terms of soil porosity, reduced bark densities, which means benefits both for the soil ecosystem and for the workability of soil. And in some studies, benefits in terms of water holding capacity were reported also. Other indicators were investigated to a lesser extent, but still even interesting to give you the outcomes. For example, soil acidification. Some studies investigated this indicator and showed that application of compost can improve, give a sort of liming effect, tuning the pH of the soil. Soil biodiversity was investigated in few studies. This indicator that is much important for us, and we will investigate further it in the future, is not provided by few standardized assessment methods, but the results depend on the approach chosen. And in this case, we can attest an indirect soil biodiversity increase in 4 studies, where soil biomass growth or soil respiration activities were investigated. And as I said, the crop yield was considered as well, and trials show that 50% of the investigated cases reported an increase of yield when compost was applied compared to untreated or chemically fertilized plots, soils. Residual contamination is less considered by the studies, probably due to the fact that the utilization of soil improvers compliant to legislation on the or quality assurance system are not supposed to cause problems, but effectively, when investigated, no concentration of organic or heavy metals or contaminants or heavy metals were observed apart from a small increase in zinc soil concentration, but just in case of high compost dosage. And by the way, I remember to all of us that zinc is always a probiotic element. So in conclusion, the conclusion of the paper and conclusion of my presentation, the application of organic waste soil improvers bring huge benefits, both to waste management sector, closing the loop of organic residues, and to soils, improving many functions that are addressed by the upcoming regulation, from carbon sequestration to nutrient cycling, soil biodiversity, water resources prevention. These benefits are associated to several features of these products, the main ones being the organic matter content and the pool of long-term available nutrient elements. An overall benefit in soil degradation prevention must be considered also, since the application of soil organic improvers plays a role in preventing soil compaction and desertification, and several long-time field-scale trials performed in different European countries, as we have shown, have clearly shown those benefits. And what ECN asks in conclusion, or what is the philosophy of ECN? ECN is not promoting a simple accumulation of compost and digestate into soils, but rather to acknowledge high-quality organic waste soil improvers as important elements in the upcoming soil health law, promoting their utilization within a sustainable farming system, meaning that the application of compost and digestate should follow good agricultural practices. And in light of encouraging good agricultural practices, appropriate training to farmers should be promoted on the long-term benefits of soil health, the practical ways of assessing its quality, the specificities of compost and solid digestate, and their correct utilization. And so I take again the occasion for thanking my colleagues of the task group of the soil organic matter for the work done and the work that will be done. And I invite you to download all the papers that I have shown you at the ECN website. So I've concluded. I am sorry. I'm sorry for my impossibility not to attend all the webinar, but the celebration of the Soil Health Day happens is still even here in Italy. So I am moving to another domestic celebration. So thanks in advance and apologize for I have to leave. Thank you.
Thank you, Alberto. Thank you for this presentation. And I also put the link to the position paper of ECN on the chat. So feel free, all of you attendees, to go on ECN website and download the full position paper. But Alberto was very clear on the results of the long field trials, and I just wanted to now launch some question for the participants on Slido. Tell me if you can see it on the screen so that you can all vote. Let's see what are the answers after Alberto's presentation. Okay, votes is still running. Yeah, some of them are saying less than 5%. But yeah, the majority is answering correctly to the answers. I don't know if Alberto wants to comment on that, or maybe he is already gone. Yeah. Okay.
I'm still
Okay,
here.
you're still here. Yes. Okay.
What do you want me to comment on? I cannot see the answers. I hope that
Uh,
most of the
uh,
people have answered correctly.
so 72% of
Okay,
the yeah, participants are going with the 25%.
which is a figure. I'm very comforted by both the answers that mean that you have listened and have been clear
Yeah.
enough, and that 25% of the compost is not just compliant to a law, but it's under a quality assurance system. That's quite important. That this should improve the confidence of the policymakers and of all the stakeholders, including farmers, on the quality not only of the product but on the way that through which this product has been produced, starting from the feedstocks and the attention that we all make in turning it into an end of waste and a valuable product.
Yeah, that clearly ensure that the safety is there. So I'm gonna close the voting now, and I will just go to the second one. So I just to be sure that everyone paid attention to your presentation. Let's see.
Ricardo, maybe you can tell us also the question. Maybe that's also
Okay,
nice
yes.
to hear this from you.
So how many long-term trials of compost application to soil have shown a significant increase of soil organic matter? This is the question. We saw on Alberto's presentations the figure, and that clearly is important data, as soil organic matter is one of the most significant soil health indicators. Okay, 89% is saying 10 out of 11 field trials. So not everyone paid enough attention to the presentation, but we will forgive them.
Let's stress the many of them that have paid
Yeah,
attention.
exactly.
The question was quite simple, but it was just a way for stressing again the main aspect that characterizes compost and solid digestate, and the way that it's an instrument for the main instrument for improving the soils into which these fertilizers are applied.
Okay, thank you. Yes, most of them is saying the correct answer, 10 out of 11. So since we are running slightly late, I will close the pool, and
I must say bye-bye, everybody. Sorry.
yes, thank you,
Ciao. Have
Alberto.
a nice soil day. Bye, and thanks for the
Thank you for
attention.
your presentation.
Thank you. Bye.
So now I want to present our next speaker. I will just say that please, if you have some question after this presentation, you can write it down in the chat, and I will address it to Mr. Barritz. Thank you for joining us today for World Soil Day. So Mr. Barritz has a master's degree in foreign science and holds a PhD in ecology and soil science. And he began his professional work in Germany as a forest ecologist for a state foreign agency, and then worked at a federal level. And after that, in 2002, he joined the Science Hub of the European Commission, the Joint Research Center in Ispra, Italy, where he was involved in the quality control of European greenhouse inventories on land carbon pools, with a focus on European forest soil monitoring. And after 2 years, he moved to the Federal Institute of Geoscience and Natural Resources in Germany as a coordinator of the National Soil Information System. In 2015, he became detached soil expert to the UN Food and Agriculture Organization, FAO, in Rome, Italy. A lot of Italian experience. And at FAO, he was involved in designing global soil information and governance. After that, in 2017, he finally joined the European Environment Agency, where he currently works, and he's involved in work on soil condition assessments, chemical pollutions of soils, and impact of intensive land use and climate change on soil health. He is the coordinator of the thematic working group Soil, and under the umbrella of the Global Soil Partnership, he is currently elected chair of the European Soil Partnership. So with no further ado, I will give the floor to Rainer. Thank you.
Mute. Hello, thank you very much for this very wonderful introduction. You can hear me okay?
Yes, we can hear you. Great.
On presentation mode. You can see my presentation?
Yes, we can see it, not in the presentation mode, but we can see it.
Oh, it's not? In my case, it is.
We still can see it, so
What I'm going to show is in my whole screen. There's a trick.
No, it's not showing it. Oh yeah, starting. We now see your screen, your computer screen.
Sorry that I need to apply a trick in order to show you my presentation, and I accidentally closed it. Now I need to find it again, but I will be fast. There we go. Here it is. And when I click on presentation now, you should see it. I don't know why I have to do this workaround with WebEx.
Let's see.
Now you should see the presentation.
Yes, perfect.
Okay, thank you again for the invitation and happy World Soil Day to everybody. Well, after my presentation, we will see whether we will be all so happy afterwards. I changed the title a little bit, but I will also address what you asked me to address related to organic fertilizers, though I'm not a super expert. And for that, in our assessment work, we need you. We have this kind of sad estimate that currently a large proportion of our European soils are unhealthy. And I'm saying European since in EEA and the European Environment Agency, we work not only with the EU member states, we also work with our neighbors. So we have we are covering in our network a total of 38 European countries. Anyway, in soil, we are looking at functions, at specific functions and services that soils are providing. And ideally, we want to see that soils perform on the left side the functions that are expected from soils so that our ecosystems can thrive, and that includes also the production. However, what we observe are degradation processes that affect soil and reduce the functions that we would expect from a healthy soil. We do assessments, that means we look at indicators at existing data sets at the European level, and then we investigate whether our European policies, in this case it refers to the EU, are doing their job, reaching their aspired targets when it comes down to different environmental activity areas. So we have the State and Outlook of the Environment report every other 5 years, and this year for the first time we also produced a zero pollution monitoring report. And usually we have then a kind of a traffic light system of what we think how soils are doing, and the past trends are in the deteriorating trend dominates red light signal, and the future trend, we expect an impact from last year's EU Soil Strategy 2030, including probably a soil health law, and that makes us a bit more optimistic that we may get out of this red zone. I will show you later why we came up with this. There is evidence that heavy metals and persistent organic pollutants are accumulating in soils. That is very worrying. Although the information that we can aggregate at European level is still very sparse, sometimes difficult to interpret, sometimes difficult to also upscale and generalize from available case studies in diverse publications. So we have also at the same time an information gap. We do found for certain metals, copper and zinc, threshold exceedances, where we can say that protection targets like groundwater safety are endangered at least, so that action is necessary. And that is the whole idea also of detecting where we stand with the current soil condition to facilitate management change or management adaptation to the challenges to create or to maintain, develop healthy soils. Also, another indication for the red signal that we decided for zero pollution or suggest for zero pollution monitoring is the nitrogen surplus, which is still very widespread. Also, soil acidification can be observed in some areas, and I will show you how we actually came up with that. What we did in order to get an idea of how soils are doing, in order to know where to do what, where we have our degradation hotspots, where is action really necessary, we had a recent 3-year project on investigating the available literature on how indicators are defined, described, specified, and with which kind of thresholds can we get an idea that protection targets or soil functions are not properly fulfilled. And that you can see in the right, we have different protection targets. Sometimes we have information about a status of water quality. In other cases, it's a status in the soil with regard to foodstuff limit values. We found also various other limit values for soil organic carbon, erosion, compaction. So we actually looked at a large variety of threats, with pollution one of the main interest areas, I would say, from the EEA point of view. That gives you a first idea of where the soil organic carbon values are below a functional limit. In this case, the soil-clay ratio has been applied, but we also compared it with long-term agricultural field experiments, very similar. It's a large proportion of soils that is under the limits that we took from the literature. For the boreal soils, we used a much higher limit value that we took from case studies, and in this case from southern Finland. And you can still say that not the limit values that we found were not applicable in all regions of Europe. That is true. It needs validation, especially in the Mediterranean. But there's indication that soils there are so depleted of topsoil organic carbon levels through erosion that it may not be very unplausible what you can see here. So looking at the current policies, for example, the revised LULUCF regulation, and also the climate targets which we need to fulfill, and the need to sequester carbon not only for fertility reasons and for various soil functions like water regulation, but also for the climate regulation ecosystem service. You can see here areas where organic fertilizers, as you described it, Alberto, in your presentation, as a nature-based solution comes into play. And that when through a soil law, for example, or whatever we will agree with the member states in the next years, will demand innovative soil restoration practices, then the application of organic fertilizers is probably one of the the first restoration practices that come into the discussion. We looked at other, let's say, soil threats or indicators of soil health, in this case related to nutrient management, nitrogen and phosphorus. You can see here massive exceedances of critical limits. I will, in case there are questions, I'm happy to go a little bit deeper. You may say, the soil doesn't really play a large role in the nitrogen balance. It's all related to the inputs. Soils do play a role because you see here it's a spatially explicit approach, and it makes a big difference of what kind of soil quality we are talking and how the different, let's say, transfer models are reacting or modeling or predicting a limit value in the point of measurement, which is in this case the soil, whereas the thresholds are taken from the endpoint level, in this case, for example, the limit nitrate concentration in the leachate to groundwater, and then back calculate it into soil. That's the way we have done it here. All this is a cooperation between us and our European Topic Center on Digital Information, and I'm happy to provide you more information about a very specific report on this topic. So definitely the N inputs are very worrying, they're very high. The protection targets that I just mentioned are not safeguarded, and the inputs need to decrease quite dramatically, as you can see, between 31 and 43% in order to really safeguard groundwater protection, ammonia limit values that also are coming from soils. Soil pollution, another area where we also looked at let's say a balanced approach between inputs and outputs, and we modeled this in a spatially explicit way. This was done by the Wageningen University. And you can see also here, in the case of copper and zinc, exceedances of quite an amount of our arable land, almost a quarter for copper. And in the report that I mentioned gives you a bit more detail on which kind of inputs are concerned for the metals investigated. In this case, we investigated copper, zinc, lead, and another one. Was that a reminder of the time? Okay. So what you see here is a list of, in fact, key facts.
Somebody has still his micro on. Yes.
I will.
Can you mute him,
Yes.
maybe, Ricardo? Okay, thank you.
Okay, thanks for
I'm
your
sorry, yeah.
questions. So what you see here is a summary of a few key facts, and that's what we are looking for. We are also working, we have started to work on a European soil condition assessment where we look at case studies, and especially for the use of organic fertilizers, we need good reviews and clarity on key facts of how they are, exactly what Alberto, what you just presented, it is really wonderful, in more detail for us to which organic fertilizer subproduct we are actually talking, and under which conditions certain effects can be reached within a certain amount of time. But you can see also, for example, from the German case study from Körde 2007, you may argue it's a little bit old. It's a very important study that looked at the qualities of inputs and also of effects in the soil. And it was very interesting to see that even for some organic pollutants, limit values, but also for copper and zinc, were actually exceeded in some cases. So I believe that the quality of products is improving. Also, when I look at the quality assurance system that you have established, in improving so substantially that it would be worth it to probably repeat a study like this and teach us on the current impact or drawbacks from applying organic fertilizers. And the synthesis, I was really debating whether I should show this to you, because we are actually in the team discussing this very, very intensively. When we add up the limit values that we investigated in relation to various soil threats, in principle, most of the agricultural soils show one or the other soil threats. And that means that in terms of functioning of soils, applying limit values from the scientific literature, where you can conclude that at least the productivity function, if not also the water provision and other functions, are impacted by a soil degradation process, then a very large proportion of soils shows an exceedance of these thresholds, which would then, in consequence, ask regional planners to incentivize land use change. And so we are developing the rationale for what are the real conditions of these thresholds, and what and how do they trigger then action on the ground. That is a very interesting, and I'm coming to the end of my presentation, from the European Joint Program on Soil. They have looked very recently on the impact of sustainable management practices. I marked here organic fertilizers and biofertilizers as sustainable soil management practices. And when we develop a soil policy and we look at degradation processes, then the idea is to have a restoration-oriented legislation that incentivizes action that improves the condition implied by different soil degradation processes. But what you can see here, when you look at the challenge in the center of the graph, and then you look at which kind of practices actually address these challenges, then you see the whole full spectrum of sustainable soil management practices addresses different soil threats. And Alberto, you also just presented it, that in fact, organic fertilizers under the conditions that you presented offers a positive solution for pretty much for a large proportion of soil degradation processes. And the challenge is now to extract more specific information that guides on site and farm specific implementation conditions. This is so generic. The level where we operate with our current recommendations is so generic that it's still hard to develop a guidance for sustainable soil management that would be at least valid for regional planners or implementers. And this is, I added this slide because I wanted to bring in the term nature-based solution. It didn't hear it yet, and I think it would be definitely good to receive more information from case studies and key facts from your network that help us to make the case, to bring this into the debate of what is responsible for the degradation that we are observing, and to which degree can very specific practices help and teach us in the actual tackling of the problem. And you can see here, I put in also some questions related to organic fertilizers. Is it really more costly? What is the potential to contaminants? How can a farmer embark let's say, the relative slow release of nutrients? How is that turned into practice for specific soils under specific climatic conditions? And so we actually need to step up into what kind of knowledge we aggregate and collect, so that this whole idea of a policy or of an intervention that looks into the current quality and health of soils and then moves into a guiding for change practices in a way that it could be even mandatory rather than optional. So I will conclude here, and thank you very much for attention, and I'm happy to receive also questions or join a discussion with you.
Thank you, Rainer, for your presentation, and thank you for providing us with the overall European data on the soil conditions. I have some questions in the chat for you. Maybe I don't know if you can answer in details to those, but let's see if that's the case. So from Rini Leisner, I hope I pronounce it correctly, says PFAS concentration in soil and compost is a big issue in the US. How is the situation in Europe? And then another one from Bodil Damgaard. Are you working with the issue of plastic residues in the compost and the consequences for the soil fauna? Those are the questions. I don't know if you want to address them.
Yeah, I'm happy to briefly comment on emerging contaminants such as PFAS. We do not have an overview of the, let's say, of the situation in Europe per se. However, in our network with the countries, we have received case studies and input so that on PFAS, we have in the zero pollution monitoring, we have kind of a highlighted case study on it. And we are aware that this is actually with an increasing amount of water analysis that gives evidence of the presence of PFAS, that we are actually facing quite a challenge. But the whole scope in terms of soils is not yet known, I would say. I would conclude that. And so we work very closely with our chemicals group and with JRC, also who extend their analysis of the European local soil inventory each time they go into the field now. And they're developing a soil pollution module. But we still have to also, with regarding PFAS, we have to see how soil relates to what we actually currently measure in the surface close aquifers. That would be my quick response. Maybe not completely satisfying, but that's my level of knowledge at the moment. And plastic, that is definitely a topic that I know that our colleagues in JRC are addressing. They're including plastic now in their latest, have included plastic in a subsample of the local soil inventory. And specifically regarding compost, I need to tell you, we are not a research, or regarding impacts to soil fauna, we are not a research center. No? We very often work together with large research projects and inject our needs and kind of drive the science policy interface so that we can extract messages from research. So we put in the needs and we extract the policy language. And you hit topics that are really highlights, I would say, in current research. And what I have as knowledge available here is still very limited on that.
Okay, thank you. Just so you know, you're still sharing the screen. So if you want to,
Sorry,
yeah,
I'm sharing now.
that's okay.
I forgot.
So there are no more questions, but I just wanted to make one for you from our side. So of course, if you have the information and you can share it, I was wondering if this future soil health law. I know that also the European Environment Agency is working in contact with the DG Environment. If you can tell us whether it will be also based on a more integrated approach that we will also consider the different objectives of the European Green Deal and the circular economy also, and then if the compost and digested, as you mentioned, nature-based solution have a role to play, since also in the report then you just mentioned the compost and digested as potential source of pollution, but you didn't mention it on the other different benefits and aspect of the organic fertilizers on nutrients and soil organic matter, for example. So the question would be if you think that this law will have a more integrated approach and also include the circular economy objectives relating to soil health, and then compost and digested, if they will play a role in that. Thank you.
Mm-hmm. Yeah, thank you for your question. It's actually, my first reaction was it's a complex question, but it's actually a straightforward question. So the Green Deal as a framework for the and the soil biodiversity strategy, then as the framework for the European soil strategy, are very of an integrative nature per se. And there was a debate and an analysis of how far and how successful under the previous strategy soil issues were included in various policies. And the Green Deal has widened that scope quite a bit. And so you can imagine that the impact assessment that is ongoing right now has analyzed very thoroughly to which extent existing other initiatives, action plans, strategies, and policies already do the job to tackle the problem that I just highlighted. And the agreement is this is not sufficient, and we need to propose a legislation that enables a framework for countries to then operate. So in terms of climate change related policies and climate targets, food security, soil protection per se, but also water protection and integration with also air policies, for example, impact of air pollution on ecosystems. No? There's also in the NEC directive an article already in another policies, but to connect to that and then to enter a restoration program that then basically countries develop, that is the gap that is not existing. So I would say of highly integrative nature, you've seen it also ecosystem services and soil functions in that context is already of an integrative topic that is actually quite difficult to tackle with the existing data. So there we have also there we have actually the limitation. No?
Yes, thank you so much for your answer. And yes, we see a lot of policies that are based on a very integrated approach, and we hope that Soil and Flow will do the same. We will see what the Commission put forward in the early 2023. So thank you again.
You're welcome.
Rainer, for your contribution, and we are really happy to have you here. And so I would move on with the next speaker. Oh no, maybe no. We have another comment on the chat, so maybe I will address that since we have a little bit of time. So nitrogen surplus. Irmgard Leifert is writing. She's saying that I lost the chat. Sorry. Okay. Nitrogen surplus in agricultural soils are often discussed, but does not consider the effect appropriate that nitrogen is needed for building up stable humus content in soils. Insofar an absolute nitrogen surplus parameter has to take into account that organic fertilizer contribute also to such a necessary nitrogen amount for building up humus in soil. So she's saying that an indicator for nitrogen surplus should be considered.
Yeah.
Do you want to comment on that?
Yeah, briefly. I did not present the nitrogen surplus. That's only, let's say, an aid in the input-output balances. But in fact, we go a step further and we apply thresholds, critical limits to what would come out of the soil compartment in view of what happens with the leachates, also with the runoff from the soil. That's what we actually looked at. And the whole dynamics about nitrogen needs, reaction with organic rich soils, organic matter rich soils, and then nitrate losses, that is something that we have weaved in, and you can actually read that nicely in the report. And I think you would be satisfied with your comment. So maybe I put into the chat the link of that report that I mentioned. That is the underlying work on the nutrient and metal balances that I just presented. And like I said, I think you would be satisfied to see your point addressed. And the second question, what is the health law? That is a very easy question. The idea is that by 2050, that usually that question is answered by a so-called target, policy target. The policy target in this case would be by 2050, all soils are healthy. That means no soil is exceeding a threshold, if thresholds are decided, or range values of what you would expect for a parameter, for an indicator in the soil, and probably defined nationally or even regionally. And none of these indicators would show exceedances of the expectancy. That's the idea.
Okay, thank you very much. I will not.
Stephanie, he just mentioned the proposal is supposed to be published as a communication from the Commission to the Parliament and the Council by the second quarter of 2023, that it's correct. And then comes a mediation process with Parliament and Council, which represents the member states. And that will take some while of negotiation before then a proposal really enters implementation as a law. No? So the
Yes.
adoption is the Commission internal processes on the basis of the impact assessment.
Yeah, for sure there will be a long process with the European Parliament and Council to approve and the proposal of the Commission, but we hope to see it for the second quarter of next year, at least the proposal from the Commission. Thank you again. I will not ask you other questions by surprise. So we will, I think, move on to the next speaker. And maybe if we have time to address some other questions, we will do it at the end of the presentation. So the next speaker is Dennis Connerup. He is a plant physiologist specializing in nutrient uptake and plant adaptation to stress. His research is focused on photosynthesis and internal transport of gases in plant, in addition to applied aspects like crop production. And he has received a PhD from Aarhus University in Denmark and had since held different postdoctoral fellowship, most of the time at University of Western Australia. And he currently is an assistant professor at the Department of Food Science at Aarhus University, where he's doing research and teaching in sustainable vegetable production, including application of compost. And he will present us with the SOILCOM project, but I will leave him to explain what it's about. So I'll give you the floor, Dennis.
Yes, thank you very much. So I'm just going to share my screen. Okay, so does it look in, is it in presentation mode?
Yes, it's perfect.
Yeah.
I believe we have already a questions for the audience, right? So maybe I can have, and in the meanwhile, maybe you can comment on that. But I will just launch the question for the participants. So with compost, you put. Sorry, I will. So the question is, with compost, you put a sponge in the soil. How much extra water is retained if you apply 15 tons of compost per hectare annually? And the option are 30,000, 60,000, and 90,000. So let's see how the people vote. Then I will give you the word, Dennis.
Yeah.
Wait, it's 54% is going with the 60,000. I believe, yeah, people have, I know, still answering. Okay, still moving. I will just close the voting now. I don't know if you can see the result.
So actually, I can't see the result, but I'll just
Okay,
look at the options here.
the majority, yeah, was having 60,000 per actor. So yeah, maybe you want to comment on that.
Yeah. So so actually, the right answer is 30,000, and it's based on this calculation that if we increase the volume by 1%, that is possible to retain. Adding compost, yeah, that is 10 liters per cubic meter. And then we have like, if we have per hectare, it becomes 30,000 liters per hectare. If we take in the upper soil, there's still a lot of extra water we can retain by adding compost. So with this, I will proceed to the presentation. So this is the project called SOILCOM, which is an Interreg project. And it, of course, involves many activities. But today I will talk about a work package about long-term effects of applying compost to soils. And first I want to show this figure where actually, this is from FAO, that shows that actually healthy soils is like a requisite for many of the sustainable development goals. And not only the goals that apply to plants, but also to flooding and climate and buildings and many other things. But today, of course, we will look at, the soil and the plants and how, this is important for sustainable development goals. And also one of the background things for this project is that our diet is changing to, becoming more plant-based. It's not like we're all becoming vegetarians, but we are, in a phase where we are, in a transition to changing the proportion. So we eat more plants, and that is important for different reasons. But first of all, the climate effects, but also, health effects, and also now prices also can actually be changing a lot. So if we look at how to produce plants in a sustainable way, in accordance with the Sustainable Development Goals, there's like several that applies to this. That's about zero hunger, it's the good health, it's about responsible production, climate, and also life on land. So if we look at compost, one important factor is the ability to add carbon to the soil. And why is this important? Well, first of all, we can look at the composition of soil, like an ideal soil here. It's like 45 mineral matter. Then we have few percent organic matter. Here it's 5, it can also be less or more. Then there's some airspace, and then there's water. And for compost, it can like change some of these abilities. So get a soil with more life, more microorganisms, invertebrates, plants. We can add nutrients by adding compost. And also the compost will like hold water and nutrients to a higher extent in the soil. We can get like a more aerated soil, better structure, and overall we have get a higher fertility. But also for society as a whole, it's important to have a good soil. And this is also related to the climate effects, because actually soil can contain a lot of carbon. So now it's estimated that soil holds like quite twice the amount of carbon than the atmosphere and the plants combined. So there's like a really high potential of adding more and storing more carbon in the soil. And furthermore, we also can use less nutrients if we have a soil that's better at retaining the nutrients that we are fertilizing with. And these overall effects will also, improve our economy and the society. So the effects for or how it works with carbon in the soil, there's like two main effects that we can use to store carbon. And that is like the direct effect of, plant litter that is stored, and some is decomposed, but also some is just stored on a more long term. But also there's another effect called the entombing effect, where you have bacteria and fungi in the soil that is like building up also like a biomass of microbial biomass that is also difficult to decompose, and some of this will also be stored. So that's like a two way of storing more carbon by having more microorganisms in the soil. And then the background for this specific study, this part of this project was that we want to look at these different field trials in different countries where we had applied compost for some years to a different extent, between 4 and 15 years. And of course, there's also depends on different soil types and climate. So this was like conducted in Denmark and Belgium, where there are some differences. And also have to say now, this is an ongoing study, so we are still collecting data, and I'm showing some preliminary data, and this is like work in progress, but still interesting to look at. So our hypotheses here, they were that, we could improve the physical quality of the soil, the structure and the water holding capacity. We would increase the microbial activity, and we could increase soil fertility, the nutrient content in the soil. And also in the end, the goal is to increase plant growth by adding compost. So at this point, we have 4 different trials in the study. Here there are 3 from Belgium and 1 from Denmark. So one is from Ilvo in Belgium. This began in 2010 with adding compost. And for this year that we looked at is 2021. The crop was fodder beet. Then we have PSKV also in Belgium. Started in 2006, and the year we looked at, they had beetroot. And then there's PCS in Belgium with hornbeam, started in 2012. And then here in Denmark, at Aarhus University, we had a trial started relatively recently in 2018, and we had beetroots in this year. And then we decided these parameters to measure in order to evaluate the effects of the compost. And they were like, in the beginning of the season, we looked at some available plant nutrients. We looked at mineral N, potential N mineralization, and also soil organic carbon, soil texture, pH. And at harvest, we looked at the yield and the residue and the N left in the soil. And then, yeah, just a quick overview here. In Ilvo, we had like the treatment was like with and without compost. It was like there was cattle manure and a non-version treatment. As SKV, we had like different kinds of compost. There's a vegetable, fruit, and garden waste, green waste, and then waste from a farm, and also compost from mushroom production. In PCS, here the crop was hornbeam, and there was added green compost in 0, 24, or 48 tons per hectare, and also compost from a company. And then here at AU, we had 2 treatments, animal manure or plant-based fertilizer, when we also considered as a compost, but also as a fertilizer effect here. Some of these results that we have so far. First, it's interesting to look at soil organic carbon. And actually we see quite clear effects in, now there's results from ILVO, Aarhus University, and PCS and PCKV. And we see actually higher effect in the compost treatment. Also in the one from Aarhus University here in the upper right corner. And this has just been applied since 2018, but still there's like a significant effect on the soil organic carbon. And then we see in the PSKV that there's different effects depending on the kind of compost, but all are higher than the ones without compost. Soil mineral N, we also generally see an effect of adding compost to the treatments. Here we see it in different soil layers, with some, that's highest in the top layer in the spring. But also it seems like compost can bind more nitrogen. If you look at harvest, it still looks like it's higher. If you, for example, look at in the study in the right lower corner, SKV, it's significantly higher in all compost treatments compared to no compost. And if we also look at other plant nutrients, here's phosphorus, another of the macronutrients. It's also generally the same or higher in the compost treatments. So again, emphasizing this effect of the compost to hold the nutrients in the top layer of the soil. Potassium, another important nutrient. We see here in the study from ILMO, it's almost twice as high in treatment with compost. So also a significantly positive effect. Calcium, again, is like the similar or higher in the compost treatments. Magnesium, similar or slightly higher in the compost treatments. And then we have hot water extractable carbon, which is like there's a correlation between this and then the microbial activity in the soil. And here we also see that the effect is like it's similar or higher in the compost treatments. And phosphorus similarly higher or the same in compost treatments. In ILVO, it's significantly higher. And then we also looked at different structures here of the soil. We have used like some of the methods here, like to use double rings to look at the water infiltration capacity of the soils. We measured the bulk density and the water holding capacity of the soils. And here is the soil density studies. So it looks like there's a little bit lower density of the compost soil, which is also what we wish and what we expect, because it's like there's more organic matter, and this like has lower density than mineral matter. So overall we get like a more loose and lighter soil by adding compost. although the effects are minor, but there's still some effects. We also looked at this visual evaluation of the soil structure, which is like a method where you evaluate the soil on a scale from 1 to 5, depending on how compact it is when you dig the soil, where 5 is the most compact level and 1 is the least compact. And here we found a little bit not as clear results so far. It looked like it's the same in ILVO and AU, and in the PCS, it looks like it's a little bit more compact in the compost treatment. So this is something we are looking into now. There's another test to look at the soil structure. It's called wet aggregate stability, and that tells us something about how well the soil is like glued together, you can say, because what happens is that when you have a lot of micro biomes in the soil, they excrete different compounds, and these act like a glue, so the soils stick more together when you add water. So this is also like a standard test to do in the lab, and then you get a scale from 1 to 8. And here, so 8 is the most where you have the most glue and the most secretes from microbiomes in the soil. And here we also saw like not a clear picture. It looks like an ILVO is slightly higher in with compost. AU, we didn't see a difference. And then in the PCS, there might be some differences, but it's not very significant. And then there's also the capacity to hold water, which is an important ability of the soil. And there's like, it's measured at saturation after 24 hours and after 48 hours. And in ILVO, it was measured at 2 different soil layers, from 0 to 10 centimeters and from 10 to 30 centimeters. Whereas at PCS and AU, it was just measured in the top layer. Here we also saw like some capacity to hold more water. For example, in PCS, we see that they are higher in general with adding more compost. There's a high ability to hold water. We didn't see a significant effect at Aarhus University in this study. Maybe there's also, it's still like at young, a long-term trial, you can say. Also at ILVO, there was not like a substantial effect on the soil water content. So some of our preliminary conclusions on this study, we are still working on and still collecting data, but it is that we can increase the soil organic C. There's a clear effect. We can increase the nutrient availability for the plants, some of the macronutrients, N, P, and K. There's a higher microbial activity in long-term trials with compost compared to without compost. And overall, what we get from these effects is that we expect a more sustainable production of crops. Yes, then I think that's my presentation. Then I think there's a question also, 2 more questions.
Thank you, Dennis, for providing us with the data and comparison of your SOILCOM project, and also for stressing that this is preliminary data and that we wish you luck with moving forward with your work on the analysis of the data. I know that from the chat, Elke from Flaco answered to a lot of questions. She's involved in the project, so she's a reliable source. And I think we have some question on Slido. So we have, I will launch now the question. So what is the value of 1 kilo of CO2? And then we have the options here, 5 euros per ton, 25 euros per ton, and 100 euros per ton. So we will see the answers are running. 25 euros have 45% of answers. It's in first position. Yeah, I think we can say that half of the participants think that 25 euros per ton is the right answer to the question. If you want to give us the correct answer, Dennis.
Yeah, yeah. So it's interesting actually because you know, it's a market price, so it has been quite low. This price below 10. Now each country has their own system for this, for the trading these certificates. It's like the emission trading scheme. So it's like internationally, it's actually the price is not so high. It can be like 10 or 25. On some local scale, actually, the prices have gone up, and some companies are willing to pay a lot for this CO2 emission reduction. And then the price actually can be 100 in some cases, 100 euro per ton. So we see like a lot of variability in these prices, and they have been going up the last years.
Okay, so a lot of people were right in the end.
Yeah.
With that answer, and I just want to launch another question here. So how many kilos of CO2 will you save by using 1 ton of compost? Which is a very interesting question. So let's see how the vote goes. So the options are 50 kilograms, 110 kilograms of CO2, or 270 kilograms of CO2 per ton of compost applied. And we see that actually they're very close, the results. The majority seems to think that 110 kilo is the correct answer. Yeah, now it's the difference is getting bigger, and it's, yeah, the main answer is 110 kilos of CO2 that can be sequestered with 1 ton of compost. So did they answer right?
Yeah, so actually that's correct. That is correct. If you just look at direct storage of CO2, of carbon, then that is correct. But also I would say that 270 is correct if you include the replacement of fertilizer and replacement of peat and the derived effects of using compost. If you use this model, you reach 270 kilos. So this is to show also that when we do these calculations, it depends on the model and how much we include in our calculations.
Yeah. So in the end, we can reach further savings with compost.
We can.
Yeah.
Yeah.
Okay, so I see that we have some questions in the chat, but we are running out of time. So I don't know if Dennis, you want to comment on those in the chat, and or maybe we can also provide the answers after the webinar. But thank you for your presentation, and thank you for joining us. I know that you were in South America until the last weekend, so thank you for being here. And now I would like to give you the final word to Crystal, back to Crystal, and I would like to thank you all for joining us in this debate, in this discussion, and to celebrate with us this very important day. And yeah, Crystal, the floor is all yours.
Thank you, Ricardo. So as we have heard from our speakers today, there are a lot of issues to tackle, but it is also possible to reverse the current trend and to restore the ecological status of European soils. We also have learned that there is more studies are needed. We have a lot of data and a lot of knowledge already, but as PFAS, emergent contaminants are already mentioned, plastics are also mentioned, and in SOILCOM, I think this also will be tackled in the future. Also on digestate, I saw also some questions on digestate in the chat. There is also the need for more research on digestate. All being said that, we also must act as soon as possible. There is really an urgency, and European institutions need to live up to their mandate and bring forward a robust soil health law, which also takes into considerations the benefits that high quality compost and digestate bring when they are applied appropriately. We also learned this today. That's also very important, that we have good agricultural practices. This all has been shown today by our speakers. They have provided us the evidence. And this is also why ECN, together with CHIC, has started the initiative of SOS Safe Organics in Soil. Organic matter is ultimately playing a fundamental role for soil well-being and consequently for all of us. And ultimately, I want to thank the speakers, all the speakers for their valuable presentations, also the participants for their questions, for their attendance, for their interest in our webinar. I want to end this webinar. I think we are more or less in time, so that's very nice if we can do so. I want you all to have a very nice day and to celebrate our soils on this World Soil Day. Thank you very much.
Thank you also. Bye-bye.
Thank you, everyone.
See you next week.